So, hello student. In the series of revision classes, we have completed our chapter system of particle and rotational motion with some important topic. Now, the relation between the torque and I, relation between L and I, many more topic we have completed. Now, in this class, I will discuss some other important topic, and in the last, I will discuss some important question that come in your previous year paper. Okay, that will be your that maybe this part will be your last part of the system of particle and the rotational motion. Okay, now I'm starting. Wait just a minute. Okay, so in the last part, we have discussed about the relation between torque and moment of inertia, relation between kinetic energy and moment of inertia, the radius of gyration, the relation between L and I. Now, in the this chapter, I will discuss about conservation of angular momentum. So, what we have discussed from the last part, we have discussed that L is equal to I omega. One of the relation is it. Now, one relation we have determined about the torque. So, torque is equal to tau is equal to I alpha. Next, we have described about the kinetic energy and moment of inertia. K is equal to half I alpha. So that were our some important relation, and the radius of gyration I is equal to mk square, where k is the radius of gyration and the value of k is r1 square plus r2 square plus r3 square by n dot rn square by n. Now in this chapter we will discuss about the most important topic, that was your conservation of angular momentum. So the name of the topic is conservation of angular momentum. Conservation of angular momentum. So what is the conservation? Conservation means the angular momentum will be constant. So what is the law of conservation of angular momentum? That in the absence of external torque, in the absence of external torque, external torque means the value of torque is 0. So we know that torque is equal to dl by dt. So dl by dt is equal to 0. And if the differentiation means derivative of any quantity is 0, that means that quantity will be constant. So L is equal to constant. If L is equal to constant, we know that L is have the relation L is equal to I omega. So I omega will be constant. And if I omega will be constant, that means I1 omega 1 equal to I to omega 2. That was your the important relation of conservation of angular momentum. That I1 omega 1 is equal to I2 omega 2. What it means that in the when no external torque is acting, when no external torque is acting, the angular velocity omega, the angular velocity omega of the body can be increased or decreased, can be increased or decreased by decreasing or increasing, can be increased or decreased by increasing or decreasing, increasing or decreasing the moment of inertia, the moment of inertia. Okay, that was the important part. Now next is here two important theorem of perpendicular axis and theorem of parallel axis. First is your theorem of perpendicular axis, theorem of perpendicular axis. So what this theorem tell us? This theorem tell us that in any plane moment of inertia about a perpendicular axis, means that axis is equal to the sum of moment of inertia of two axes which are perpendicular to them. Suppose that was your y axis, that was your z axis, that was your x axis. Now I am taking any point A here. So A will be here. So this distance of A is known as x. This distance of A is known as y because it is parallel to y, and this is parallel to z. So it is equal to z. So according to this theorem, in any plane, in any plane, moment of inertia about a perpendicular axis from a point, about a perpendicular axis from a point is equal to the sum of, is equal to the sum of the moment of inertia about two axes which is parallel to the plane and passing through the same point. And passing through the same point. That means Iz is equal to Ix plus Iy. The moment of inertia of z axis is equal to the moment of inertia of x axis plus the moment of inertia of the y axis. Now, how you can prove it? In triangle OAB, suppose this point will be O. So that was x, that was y. Okay. So in triangle OAB, in triangle OAB, z square is equal to x square plus y square. Now multiply both side I. So I z square is equal to I x square, I x square plus I y square. That means moment of inertia about z axis. That means sorry, if I multiply m both side, multiply by mass both side, so m of z square is equal to m of x square plus y square. So mz square is equal to mx square plus my square. What it means, that moment of inertia about z axis is equal to moment of inertia about x axis plus moment of inertia about y axis. So that was the your theorem of perpendicular axis. That means if a axis is perpendicular to a plane in which both are parallel to each other, so parallel or perpendicular to each other, so the moment of inertia of that axis is equal to the sum of the moment of inertia of those two axes which are perpendicular to that. Okay, now next theorem is your theorem of parallel axis. Next theorem is theorem of parallel axis. Now what this theorem tell us, it tell us that the moment of inertia the moment of inertia about any axis which is parallel which is parallel to the axis through its center is equal to moment of inertia about the axis passing through center plus the product of mass of the body and square of the distance between them. Square of distance between two parallel axes. Two parallel axes. Now this was the theorem of parallel axis. Let's suppose that was your body and its center is at O. And this body has mass m at distance d. We have to find moment of inertia of that. So the moment of inertia of that body is equal to the moment of inertia of the line which is passes through a center of mass plus the sum of mass and the square of distance between them. That means I is equal to ICM plus MD square is the theorem of parallel axis. Okay, so that was your theorem of perpendicular axis and theorem of the parallel axis. Now I'm discussing some important question that comes in your previous year. So the first question is the difference between the center of mass and center of gravity. I have proved that. Now next is state and prove the perpendicular axis theorem. I have proved that theorem. Now next is state parallel axis theorem. So only there is a given as state parallel axis theorem. There will be a no proof of that theorem. Now next is state and proof conservation of angular momentum and explain the principle of conservation of angular momentum with example. Okay, now that was your question. Now first question is state and proof perpendicular axis theorem. State and prove perpendicular axis theorem. Perpendicular axis theorem. Now I have proved that one. Second one is your distinguish between center of mass and center of gravity. Distinguish between center of mass and center of gravity. Center of mass and center of gravity. Center of gravity. That question I have also discussed earlier. Next question is your state and proof principle of angular, sorry, state and proof principle of conservation, principle of conservation of angular momentum, principle of conservation of angular momentum, angular momentum. Explain the principle, explain the principle explain the principle of conservation of conservation of angular momentum with example, angular momentum with example, angular momentum with example. So student, I have discussed earlier the first part, that the proof of conservation of angular momentum, and second part is that example principle of conservation of angular momentum with example. Now I'm discussing. I can prove, I can solve this question. So I'm solving. In that question, I will solve both the part. Okay. So first one is your state and prove the principle of angular momentum. So the angular momentum of a body, angular momentum of a body remain constant, remain constant when the external torque is zero. When the external torque is zero. The external torque is zero. That means L is equal to I omega is constant, or you can say that I1 omega 1 equal to I2 omega 2. Okay. Now it's proof. I have discussed earlier that in the absence of any external force, torque is equal to zero. So dl by dt equal to zero. So that means L equal to constant. L equal to constant means L1 equal to L2. That means angular momentum of first at initial equal to angular momentum at final. So I1 omega 1 equal to I2 omega 2. So that was the proof of it. Now example. First example is when a man is stressed out, when a man is stressed out, it arms. When a man is stressed out, it arms stand on a turntable which is revolving which is revolving, then its moment of inertia is high. Then its moment of inertia is high. Moment of inertia is high. If we fold its hands, if we fold its hands, then its moment of inertia decreases. Then its moment of inertia decreases. Moment of inertia decreases, and the angular velocity increases, and the angular velocity increases, but the angular momentum remains constant in both the cases. But the angular momentum but the angular momentum remain constant in both the cases. Remain constant in both the cases. In both the cases. No, just a minute, huh? I'm taking its image. I give you the image of that one. Okay, just a wait, huh? Wait, huh? 1 minute, 1 minute. Now see here that image. In the first case, you are watching that person, a girl, open his hands. If it open its hands, its moment of inertia is large. Why it is large? Because I is equal to mr square and I is equal to mr square. What it means that its moment of inertia is increases because its distance increases. And if the distance increases, so omega will be small. Now in the second case, you are watching that it is in the second case you are watching that it folded she folded its hands. So after folding its hands, its distance will be less. If its distance will be less, so its moment of inertia will be less. And if its moment of inertia will be less, so angular velocity will be higher. So that was the example of conservation of angular momentum. I think you have understand that topic. That I is equal to mr square, and if the distance is increases, so I is increases, and I1 omega 1 equal to I2 omega 2. So omega 1 equal to I2 upon omega 2 upon I. So omega is inversely proportional to 1 upon I, because I omega is constant. So if I is increases, so omega is decreases. And if She folded his hands, so its distance will be less. Its distance will be less, that means I will be less. And I will be less, which means the angular velocity will higher. So that was your example. Okay. Now next question is, wait just a minute. Next is your state theorem of parallel axis. Theorem of parallel axis. So what is the theorem of parallel axis? I have discussed it earlier that the moment of inertia about any axis which is parallel to the axis through its center of mass is equal to the is which is parallel to the axis through its center is equal to the moment of inertia about the axis passing through the center passing through center plus the product of distance between them. Passing through the center, the product of mass of the body and the square of distance between the two parallel axes. Now that was your theorem of parallel axis. Now what's the its proof? Okay, its proof is not so much important. It is not given to prove that theorem, but I am giving you proof. Suppose that was a body and it was its axis PQ. That was your second axis AB, and the distance between them is x. Now IPQ is equal to the mass of the distance between them plus x plus d whole square. And what is the d here? D will be the perpendicular distance from its axis. Okay. So mx plus d whole square. So it is equal to sigma m. If you open it, so x square plus d square plus 2xd. Now, if you multiply inside, so you will get sigma m x square plus sigma m d square plus sigma m 2xd. You have to neglect that term. So IPQ is equal to sigma mx square is the value of rotation of that AB. So IPQ is equal to IAB plus sigma m d square will be the value of will be the proof of the theorem of parallel axis. But that was not so much important. Only the in examination theorem of perpendicular axis will came. And if this theorem is came, so you have to write only statement of it. There will be a not any proof of it. Only the statement is come has come in the examination. Okay. So that was your question. Now the next question is, state and prove the law of conservation of energy. That's a listed types. Next question is your define the torque, find the torque of a force, find the torque of a force, torque of a force 7I plus 3J 7i plus 3j minus 5k. 7i 7i plus 3j minus 5k. About the origin, about the origin, the force acting on the particle, the force acts on a particle whose position vector is I minus j plus k. So you have to find the value of torque. So here what we have given, we have given the value of force. Force is equal to 7i plus 3j minus 5k, and the value of R will be I minus j plus k. Now the torque is equal to force into perpendicular distance between them. Now if you take I, j, k here, so 7, 3 minus 5, and the value of I is 1 minus 1 and 1. Below I have to write the coefficient of I cap of F factor, and below the j I have to write the coefficient of j cap of F factor. So that was 3, and below the k I have to write the coefficient of F factor, coefficient of k cap of F factor, that was minus 5, and the coefficient of I, j, k in R is 1 minus 1 and 1. Now open it by row. So I cap is equal to, take the determinant. So skip first row and first column. So 3 minus 1 minus 5 1. Next is minus of j, determinant 7 1 minus 5 1, plus of k 7 1 3 minus 1. On solving you will get I equal to 3 into 1 3, minus of minus minus 5, it became plus 5, minus j 7 minus minus of 5, you will get plus 5, plus k minus 7 minus 3. So 3 minus 5 is 2. So 3 minus 5 is 2, minus 2i minus 12j and minus 10k will be the value of minus 7 minus 3. Just a minute, 7 minus minus 1 minus 7 minus 3. So that was your value of torque. Torque is equal to minus 2i minus 12j minus 10k. Now next question is, define angular velocity and proof v equal to r omega. Define angular velocity, angular velocity and proof v equal to r omega. So what is the angular velocity? Angular velocity is omega. So angular velocity, angular velocity is defined as omega. It is defined as the rate of change of angular displacement with time. So angular velocity is, it is defined as, it is defined as the rate of change of, the rate of change of angular displacement with time. Angular displacement with time, with time. So the value of omega is d theta by dt. d theta by dt. And we know that theta is equal to, since theta equal to arc upon radius, arc upon radius. Now, take the example, suppose this is the circle that was its displacement from A to B, and that arc is AB, which is its displacement. That was your angular displacement, that was R. So arc is AB and radius is R, and the value of AB is displacement and R. So theta is equal to S upon R. So put theta is equal to S upon R in the expression of angular velocity. So omega equal to d by dt of S upon R. Now take 1 upon R common. So ds by dt. Change of displacement with time is equal to the velocity. So omega equal to 1 upon R v. So v equal to R omega will be the value of velocity, or you can say that the relation between linear velocity and the angular velocity is v is equal to R omega. Okay, now another question is, we have another question of that factor. Now the next question is, the moment of inertia, the moment of inertia of a flywheel making 300 revolution per minute, 300 revolution per minute is 0.3 kg per meter square, sorry, kg meter square. Find the torque required to bring it in rest, to bring it in rest in 20 seconds. Now, what is given in the question? The moment of inertia of flywheel making 300 revolution per minute. So we know that omega equal to 2 pi upon t. Okay, 2 pi into number of revolution upon t. Okay, so 2 pi, what is making 300 revolution per minute? Minute means 60 seconds. So we have to convert it in a second. So you will get 10 pi radian per second. So that was its angular velocity. Okay, that was its initial angular velocity, because find the torque required to bring it in rest. So we have final velocity is equal to 0, and what we have given time, time is given 20 second, and I is 0.3 kg meter square. So what is the formula of torque? Torque is equal to I alpha. Alpha is rate of change of velocity with time. So we know that omega equal to omega naught plus alpha t. So alpha is equal to omega minus omega naught by t. So I is equal to omega minus omega naught by t. Omega means the final velocity. So I is 0.3 and omega final is 0. Omega naught is 10 pi and time given is 20 seconds. So the value of it will be minus 0.3 pi by 2, which is equal to minus 0.3 into 3.14 by 2. So you will get 2 1 ja 2, 2 1 ja 2, 11, 2 5 ja 10, 2 7 ja 14. So 3 7 ja 21, 2 balance, 3 5 ja 15, 16, 17, 3 1 ja 3 and 1 4. So 0.471, and what is the unit? It will be Newton meter. So that was your relation between, so that was your torque which was required to bring the body in the rest. Okay. Now next question is, wait, the next question is, maybe all previous year question is completed. Define angular velocities again. Express the term average angular velocity. Define v is equal to r omega is again angular acceleration and torque. Establish the relation between. Now next question is here. Define angular acceleration. Define angular acceleration and torque and torque. Establish the relation between them. Establish the relation between them. So what is angular acceleration? Angular acceleration. Angular acceleration is defined as the rate of change of angular velocity with time. So it is defined as the rate of change of angular velocity with time. The rate of change of angular velocity with time. The rate of change of angular velocity with time is known as angular acceleration. It is denoted by alpha. Alpha is equal to d omega by dt. Okay, that was your angular acceleration. Now next is torque. Torque. You can write the definition also, that the product of force and the perpendicular distance between them is torque. And the next definition is the rate of change of angular momentum with time. The rate of change of angular momentum angular momentum is called torque. Is called torque. The value of torque is dl by dt. That means change in angular momentum with time. Now, we also know that torque is equal to force into perpendicular distance between them. Now, consider the body, therefore finding the relation between them. That is y, that is z, that is x-axis, and the body is like that. It have mass m1 at distance r1, mass m2 at distance r2, mass m3 at distance r3, and mass mn at distance rn. So consider a body having masses m1, m2, and 3, having masses m1, m2, m3, mn at distances r1, r2, r3, rn. At distances r1, r2, r3, rn are constant angular acceleration, moving with constant angular acceleration, with constant angular acceleration alpha, because the body is moving whole, so acceleration, so they have same angular acceleration. So the torque act on the each particle will be torque acting on particles will be tau 1, tau 2, tau 3, tau n respectively. Now the value of tau 1 is equal to F1 into R1. Force is mass into acceleration. So M1 A1 into R1. So we know that torque equal to F1 into R1. F1 equal to M1 A1 into R1. A1 is alpha into R. So M1 alpha R1 into R1. So M1 alpha R1 square. So M1 R1 square alpha will be the value of tau 1. Similarly, tau 2 equal to M2 R2 square alpha and tau 3 equal to M3 R3 square alpha and tau n equal to Mn Rn square alpha. Mn Rn square alpha. So the value of total torque tau equal to tau 1 plus tau 2 plus tau 3 plus tau n. The value of tau 1 is m1 r1 square alpha. The value of tau 2 is m2 r2 square alpha. The value of tau 3 is m3 r3 square alpha. And the value of tau n is mn rn square alpha. Now take alpha common from it. So you will get m1 r1 square plus m2 r2 square plus m3 r3 square plus mn rn square. Mn Rn square. Now that was the value of sigma I is equal to 1 to n mi ri square. So that was your moment of inertia. So tau is equal to alpha I will be the relation. Tau is equal to I alpha will be the relation between angular momentum, angular acceleration and torque. It was also came as the also came in the such a way that you have to find the relation between torque and the moment of inertia. So you will have to solve the same derivation for that. Now, if any question is left, maybe I have completed all the question of that chapter. So students, that's are your some important question. Maybe all the question is ended now. Just complete. And the most important question which have repeated 5 times is defined angular velocity and derive v is equal to r omega. Okay, so you have to remember that question. I think that I have completed whole part of that chapter. If you have doubt in any topic of this chapter, so you can send the question to ma'am or sir. So they will send me, and I will solve that question in this YouTube session. Okay, that's all for today. If you have any doubt, then you can send that question or doubt or any topic you have doubt. So you can send that topic to sir and ma'am. They will share with me, and I will solve this those questions and clear your doubts in the live video. Okay, thank you everyone. That's all for today. In the next chapter, in the next video, I will discuss another chapter, okay, which I have left.